All right, welcome back to another coding session with Bangalang. Language is coming along really nicely. I'm starting to really enjoy how it looks and some of the things we can do in it. We still have a few features to go. We did start on this one, so it would make sense to continue, but it doesn't sound that exciting. This one sounds more exciting. So let's try this one. Custom allocators. I've always thought that the way we do allocators at the moment is not quite what I wanted it to be. What I would really like is if I could have like an array of ints or something, then the allocator could be any procedure that has the right signature. So then anyone could provide a procedure. Anyone could create a procedure with the right signature and put it here. So the internal one that we have is heap. I'm going to change it so that it's os.heap. And let's see how we can go about doing this. And just to sort of round out the test, let's do something like this. So that we print out, we set one of the integers and we print it out. But let's go about updating this so that anyone can create a procedure and put it here. So that's a grammar change, because at the moment an allocator can just be an identifier, but now I want it to be a right-hand side expression. So you don't have to directly put the procedure name here. You could, there could be, well, I guess it could be like if blah os heap. Oh no, well that doesn't actually work. I guess if blah, no, I guess I don't really have a way of doing it yet, but you could have like some proc and this procedure could return an allocator. You could do something like that. I'm having trouble sort of thinking of some real examples at the moment, but anyway, it doesn't have to be just a name here. It could be any right-hand side expression is what I'm trying to get at. So let's update our parsing so that it does that. What do we change? Left-hand side declaration. So yeah, so the allocator now needs to be a node. Get in there. We'll do it with this one soon too. And it'll be the result of parse right-hand side expression. Makes sense? The parsing code is very, very clear. I like it. Okay, so that's parsing and grammar updated. This is where it starts to get tricky. So the next thing is we need to actually create all these core allocators that we have. We have, let's see, what do we have? We have extern, none, stack, static. These are all the ones we've used so far. And I left this one on purpose because I want to make a new one called code. At the moment, static kind of has two uses. It can be a static variable and it can also be static code. But I want to differentiate that. So I'm not sure what the best name is, but I've gone with code so far. So because a lot of our allocators have these names and I'm making these globals, the actual declarations with allocators should still work. And we never actually explicitly said static where we now need code, so I don't think we need to do any updates for that either. But what are these going to be? Well, I think they're going to be like identifiers. So I guess they would need a value which is the same. Oh, already had a value. And they will need some data type, which we haven't got yet. So we need to figure out what the data type is for these. Let's see, if we create an allocator type node, which is make node, I guess, type equals dot type and value equals, yeah, they're procedures. And every procedure needs to have one child, which is the parameters. Oh, it's like a container for the parameters. And optionally, it can have a second child, which is the return type. So I kind of made this because this is like the common thing. And so now I'm going to make multiple different types of allocators. So these are like instances of allocators. And now I'm going to make multiple types of allocator. So I think the first one is the code allocator. Let's just call that allocator. Allocator, type allocator. So yeah, just for convenience, I made this allocator thing so we can just clone it and then add what we need. So a code allocator has a parameter. So we're going to add a child here, which is an assignment, because parameters are assignments. They're assignments because they might have a default value. So it's like blah equals 4 or something. It could be an assignment. And so the left-hand side of this assignment is going to be an identifier. The value, we'll call it source. So it's like, you know, for a code allocator, although we're never actually going to call this directly, it would make sense for it to take in some source code. And that source code would have a string data type, but string is not defined yet. So let's say string is a slice of U8s. U8 does exist, so we can use that. Program.identifiers U8. Oh, this would be code allocator. So yeah, string type is what we're saying the source parameter is. And then we're also going to add, well, I guess a string type as the return type. So that's a second child to this. So that's it also returns a string. That's what I'm calling a code allocator. I'm going to make a memory allocator. Memory allocator returns a, let's just grab this one, returns a reference to a U8. So that's like it's basically a pointer to a U8. So it's just, that's what I use to mean just a pointer to some data. It's just, you know, you allocate some memory, you get a pointer back. It also has a parameter which is the size, and the size I would like to be a U64, but at the moment it's an I64. So let's say I64. So that's the memory allocator. I'm going to make a nil allocator also, which does nothing, so it doesn't have any parameters or any return type. So that's just good like that. And then the last one is the static allocator. Static allocator, I think I won't add any parameters, and the return type will be, I don't know, I'm just going to call it an I64. It doesn't really matter, actually, to be honest. But the fact that these are all unique signatures means that I can differentiate between them. We'll come to that later on. So this static allocator, I'm going to say that stack and static are both static allocators because they both happen at compile time. I mean, this naming is, I mean, everything's up for review, really. But that's what I'm going to go with now. Extern and none are both nil allocators. Does it make sense for extern to be a nil allocator? Or is it a static allocator? I don't know, but let's just leave it like that for now. And this is a code allocator. So we don't have any built-in memory allocators, which reminds me that we should probably actually add these. So these are also types that are available. They're global types. And code allocator. Why is this a problem? Oh, because it needs to be allocated type. That should be string type. Okay, so I think that has defined our allocator types and our core allocator instances. So now there's going to be a whole bunch of errors because I changed the allocator to be a node. So when there's like just an assignment like this, it's actually kind of easy because I know that the identifiers has these core allocators, so I can just say get the stack allocator. So instead of just a string, this is the proper stack allocator. Here's a static one. It's the same kind of thing. So we can just do the same thing here. Is there anything else like that? Allocator equals GLSL. That one's a little more complicated. Let's leave that one till later. Was that all the errors that came up? Come on, there's got to be more errors than that. This get allocator, I'm actually not convinced that this is needed. So let's cut this out and then we should get a whole lot more errors, including this one, which we'll come back to because it looks tricky. What else we got here? Procedure. Okay, so this is where these different types of allocator come in, because these, I think in this case when I say static, because this is a procedure, it actually means code in the new terminology. So these are both, they're code allocators, code type allocators. And the way I want to check that is, no, it's not slice. I want to do a coerce type. So if the allocator that is on the procedure, if the data type is the same as, no, it's the program, isn't it? Program identifies the code allocator. So that's that type that we created. Maybe I'll leave this open. See, it's this type node that we created. So it's the type of a procedure that takes a string and returns a string. So basically we're saying that if the data type of this allocator matches that procedure signature, then we call it a code allocator. And that's actually what we're checking here. If it's a code allocator, but we haven't provided a procedure body, then we say must provide a procedure body when using a code allocator, I guess. It would be nice if we did have say which allocator we tried to use, but the thing is, because it's a right-hand side expression, it's kind of hard to really grab a name out of it now. And down here we have something similar, extern and none, which, remember, we said extern and none are both nil allocators. So here we can do the same thing, but we can check it against a nil allocator. And if it's a nil allocator, then we say you can't provide a procedure body when using a nil allocator. Cool. Yeah, that's kind of, I think that was kind of my thinking behind having these both nil allocators, because they tend to be grouped together. And these tend to be grouped together. Okay, so that's procedure done. I have a feeling we're going to need that kind of thing more. Yeah, so here now, so this is when we're generating a procedure. So we've already established that it's either a code or a nil allocator by this point. I think it shouldn't get to this point if it's anything else. Yeah, so it should be extern. I'm going to rename this one GLSL to compute shader. We'll get to that later on. None or I want to explicitly say code and not allow anything else. Let's see if that works. I feel like I tried to do that before and it didn't work, but let's see if we can get it to work. So here now we can say just .allocator, and I'm just going to say the allocator value, which does limit things. Like I said, you could put a right-hand side expression, any kind of right-hand side expression. That's not going to work here. So for procedures, you can't do that really. So maybe we need to improve that somehow. Better. Need to do better. And I kind of want to reorder these because you know how I'm a stickler for having everything in alphabetical order. There we go. What's this error? Allocator equals GLSL. So we're making a static variable, but we know what the allocator was, and I think we're basically just passing it along. So I think we can just do that. This is making the static variable that contains the GLSL code. Might end up changing that to compute shader or something instead of GLSL. It's kind of the new terminology. And again, we'll say value, but again, it's like this is not the best way to do it. But it'll do for now. I think it will just say to do better down here as well. Okay. That's right, we weren't going to touch that yet because it looked scary. Let's have a look what else we got here. So I think this is just confirming that it's a stack allocator. So for an individual allocator, what I thought was, so in type checking of an assignment, when we type check the left-hand side and we establish that it's a declaration, then I'm going to make a separate procedure, but like type check allocator. I don't like how the context is on the, I want to put the context on the left, but I also don't want to make the procedures in this file inconsistent. I'm going to make them all consistent at the same time. So let's call this type check allocator. Okay, so if node.allocator is null, so if we haven't provided an allocator, then we need to do, so yeah, this is when something gets declared. Because we don't have that, we got rid of that procedure, this one here, get allocator, and kind of the reason for that was that it would do this thing here where it would get the default allocator. So instead of that, when we declare something, we're going to apply the default allocator to it if there is no allocator already applied. So it equals context.program.identifiers. And I guess we're checking like if the node data type is procedure. And if it is, we use code, actually. Code is the new one, otherwise we use stack. And we know there's a data type because we've gone into this if. Yeah. And if that's the case, we're done. Okay. I'm going to skip out early because there's some other ways that we can do things also. So another thing I kind of want to do, and the reason that I kind of got onto this now is because here I want to be able to just say, I want to be able to just do this. Just not equal context.program.identifiers stack. Like that. For that to be the case, the object here and the object here need to be the same. You know, they need to have the same, they need to be pointing, they're both pointers, but they need to be pointing to exactly the same object. And that's why in here, I want to have a list of core allocator names. And we'll put, what is it, code, memory, no, code extern, none, stack, and static. Those are the built-in ones. And then we're going to search for those. So I guess this is like in the case that the allocator supplied is an identifier, because remember it could be any expression. So if it's an identifier and it's not a member, so that means that we just gave an identifier basically. There's no fancy expression or anything, it's just an identifier. And if that identifier matches one of the core allocators, like so, then what I'm going to do is I'm going to set the allocator to be that global allocator. So now this is the same, pointing to the same object as this. So that should make this work. That's the idea. And if we got through here and still nothing has happened, then we need to because it's a right-hand side expression, we should probably type check it to make sure that the expression is all good. We don't have any expectation, we don't have any strong expectation that it should be a specific thing, but we do, I think users should only be able to create, I think if for custom allocators, it can only be for code or memory. You can't make a custom nil allocator or a custom static allocator. I don't think that really makes sense. So here's our condition thing. So what did I say? It needs to be code or memory. So now I'm saying that the allocator data type, because it's been type checked, it should have a data type now, should match a code or memory allocator. And if not, then it's not a valid allocator. You can't use it. Cannot maybe just cannot apply allocator with type, and then we get the type name from here. There. So if you try to put an allocator in there that has the wrong type, you should have problems. Well, we're not going to be able to compile yet, but like if I do this, like 42, maybe I'll say I64, so it actually has like a concrete type. Well, I'm curious what both of those do. I mean, none of them make sense. Obviously, you can't allocate from a number, but that's kind of the point. I want to see what error message comes up. Okay, I think I'm pretty happy with all this type checking. Looks like assignment has an error. Let's just check. We took care of that one. This one was scary. This one, I'm just leaving open because we probably need this again. And I think we do need it here because I think this is basically saying if it's a memory allocator, right? These are memory allocators. So let's go like that. Memory, and it should be the left-hand side, right? Yeah, allocated from the left-hand side. When using a memory allocator, like so. This here I kind of actually don't like. Like, effectively we want to come in here if it's a declaration. And right up, man, this file's way too big. And we have this check here to say, like, is it a declaration? So I was kind of thinking we should be able to just say like this. I think that's nice and simple. And what do we have here? Okay. This is the guts of it. This is the guts of custom allocators, I think. Because the only custom allocators we really support properly at the moment is memory allocators. You can't just create your own code allocator. It won't work. But a memory allocator, you can. And at the moment, it is like looking for a memory, an import called memory, and then it's looking for, it was looking for a procedure name called allocate underscore allocator name. But now it should be as simple as get the allocator, which is a procedure, and we're calling that procedure. So the first child should be that procedure. Like so. Should we clone it? It is going to get type checked. I don't know that we need to clone it. I guess we'll find out. We'll get some errors if we should have cloned it. I kind of don't like to clone things if I don't need to. These ones needed to be cloned. Although with the new way that we do our data types, previously it was an issue to type check something, a portion of AST twice. But I think now the way we do data types, because it doesn't keep appending data types, it just replaces the existing data type. No, but there still can be problems, especially with assignment, because this is how it tells if it's a declaration. And once it's been type checked, everything has a data type, so you can't type check it again. Okay, only type check once. Okay, so probably we should make a clone then, because this allocator we could be using many times, the same allocator. So we don't want to, cause trouble. All right, that looks good, I think. Let's see what we have left. Okay, this is generating an assignment. And it looks like we're just switching on the allocator. So I think we can just switch on the allocator object itself and say, like this. Because if it's a core allocator, it should match like that. Stack, static, seems to be working. But these are not it. I think if we manage to get here, it should be, we shouldn't come here with an extern. We shouldn't come here with a code allocator. So I think the only other thing that it could be is a memory allocator. And so we're just going to say the default case is a memory allocator. I think that should be okay. We did match it against heap and VRAM before, but now that there's custom allocators, it could be, it could be anything that the user creates. So we can't have like a certain list to choose from. Stack and static. So that is, those are the static allocators. I'm still a little bit unsure about, because it's kind of arbitrary, I feel like, the way that I've grouped these allocators into types. Ooh. But yeah, it's good enough for now. Okay, what else we got here? Identifier. This is something that I actually want to kind of take off and just see if I can figure out another way for it to work. Okay. This looks like a complex one. There's lots of allocator conditions. So first it was saying if it's extern, GLSL, none, static. So that kind of implicitly includes code. So these two are nil. These two are code. This one is static. I think we could invert this condition and say that it can't be a memory allocator and it can't be the stack allocator. I think we can do that. I think here it's probably just node, is it? Get allocator from node, yeah. This feels a bit fishy that I'm having to grab this type checking stuff, although it looks like it's not the first time that I've been grabbing type checking in this file. Oh yeah, but it says hacky. Oh well. So if it's not a memory allocator and the allocator does not equal context dot program dot identifiers stack. So it's not a memory allocator and it's not the stack. Then we go on here. These are nil. So it's saying that if it's not a nil identifier. But this also I want to like take a step back a little bit here. This is when we're generating an identifier, right? So we're saying, okay, in the assembly, how should we refer to this identifier? And this block here is basically saying, should we refer to it by name? So that's why it's grabbing the name. And if we go down below this if, then we take that name and we either create an immediate or a memory from it. And this block here is creating a qualified name. Or here, they're both qualified names. So basically this is saying, should we qualify the name? And this is saying, should we use a name? So yeah, memory and stack variables should not use a name. They should use addresses, you know, either stack addresses or memory addresses. Everything else should use a name. So that feels right. Here, it still doesn't feel best, but I think what I'm going to do is say that the allocator should not be extern. So for extern variables, we just use the plain name, and for everything else, we namespace it. So extern variables, so far, I've used them just for integrating with C. So C variables, they should not have namespaces added to them, right? You know, they're just straight up just the names. But in the future, we may come across situations where the extern is actually other Bangalang libs that contain namespaced variables. So then extern should have namespaces. So I'm going to add a little note here to say like something like this. I want to create a directive something like this. And then this condition here would basically check for this directive instead. And that's the only time when it would not namespace. Anyway, that's something for another day. Right now we just use it for C, so it's fine. But I think that's all good. What else do we have here? I hate this whole contains allocations business. This is how we know if an expression contains allocations, and then we have to do special things because we can't use addresses relative to the stack if the stack pointer is moving. You know, if we grab an address relative to the stack, and then we move the stack pointer, then this address is now incorrect. So we have to do a special handling if there's allocations. I think I'm just going to take this off for now. So anytime there's a call, even so for extern calls, the reason this is here because if you do a C call, it would never do an allocation. But I want to revamp this whole thing later, so I'm just going to, just for ease, I'm going to do that. What is this? Is visible nested. Maybe just to make this more clear, it's like is visible in nested proc. So generally, like types, modules, they should be visible. And I've also said extern, GLSL, none, static, which also implies code. Code, static, none, So this feels pretty familiar, actually. I think this is actually the same condition that we had just before, which I think was generation of an identifier. Yeah, I feel like it's this condition. Effectively, if we flip it on its head, it can be any code allocator, it can be any nil allocator, it can be static. So the flip side of that is it can't be memory and it can't be stack. And then I thought maybe I'll just take these first conditions here and say if that or that, return true. Just handle these easy ones first. Are we in type checking? We are, so we don't need to do that. The node is the identifier node. So we need the context, it looks like. There, that seems happy. We need to change this. Yeah, I think that's enough for now there. Let's see what else we've got. When we do a call, we check whether it's, I think we basically just check if it's external or not. So it's like allocator equals so that's how we know if it's an extern. So here we're saying it's not extern. Here we're saying extern. And down here we're saying extern. Okay, so this is our last one. And I was kind of avoiding it. So here it's like static. So like I keep saying, static implies code. This is a static procedure, right? So it might actually replace code. I mean, replace static. Static procedure should never have a static allocator. It should either have a code allocator or a nil allocator. So this is another one we need where we need the context. It's kind of a pain in the ass because this is currently in the AST module. So I think we need to take this out of AST. This is kind of why I was avoiding this. I don't like doing this, but let's put it here. Something I had noticed before, and maybe I'll clean this up at the moment. See, look at this. We're in the AST package, but we have this AST prefix because we're importing AST into AST. Doesn't make any sense. So yeah, just wanted to clean that up. Okay. So, yeah, so we need the context. So let's put that in. And then we can check these. So we want to check for nil, and I think actually code is right here, right? Yeah. I think I said it should be code or nil, right? Code or nil. Yeah. So we can return code allocator or nil allocator. think so. That's probably going to break a bunch of places that were pointing at static procedure. Now we need to pass the context in. This place is special. Let's get back to that. Let's just tidy up the places that we can for now. I think we've got a lot of this stuff done now. Context. This is in generation. Shit, so we don't have a context. That makes it even more annoying. What do we actually need from the context? I think we just need the program, so we could potentially just grab the program like that. I don't really like this so much, so just put a note. Okay, so now everywhere that I just fixed is now broken again because we need a dot program. Dot program, dot program. Dot program, dot program. Okay, that's the one that I said needed something special. So the reason is that this is the, I want to clean this up, but this is a pre-loop, the pre-processing of the statements, I like to say. Like this is the main type checking loop when we have a set of statements. This is the pre-processing. So at this point it has not been type checked. So we don't have the allocator information yet. So this static procedure, which is kind of relying on that, is not going to work. But really what we're trying to do here is say, like, is this a declaration of a procedure? That's basically it. That's good enough. Like, it doesn't matter that much if we get too many identifiers in. Well, it kind of does, but I think that would be a good condition. So this is what a declaration is. If before type checking, the data type is not null, so left-hand side is this guy. And we also, before we check that, we need to just double check that, because we don't know it in this context, that it's an assignment statement. And then we want to say that the data type needs to be a procedure. So if it's an assignment statement, it's a declaration of a procedure. Boom, then we add it. Probably should have pressed debug because I'm sure there's going to be errors. Import has not been declared. Interesting. So it's not finding it in here, so I kind of want to see why. Let's step into here. It should be finding it in the program. Well, yeah, because it's import, right? Import is in the program. Let's just double check that that's what we're looking for. Identifier, yeah, import, okay. Yeah, so program, it should be in here. Yes, we find it. So I guess this visible check fails. It thinks it's a memory allocator. Oh. I should probably actually put memory allocator there. I hope I haven't done something like that somewhere else. So did that fix that? Now we have an error. Oh, cannot apply allocator with type any type. Yes. Type any number. So that's playground 15. Yeah, so that's an error. And what? Ooh. Should probably all return that. That might be the issue because it didn't all return. Convert SI index. So it's trying to convert the SO index and it's coming across something, an identifier. The identifier I64, which doesn't have a data type. Huh. I wonder if that's still an error now that yeah, still does that. So I think it's this here. I mean, I'm doing some crazy shit here that I shouldn't be doing. Maybe this highlights a bit of an issue where, like, you know, we're type checking this expression, and before we get a chance to add type information, which would happen here, we're doing this. So we could potentially come across stuff that doesn't have a type. I feel like that's kind of valid that it might not have a type. So maybe we'll add a nil check there. Yeah, I think that's probably a safe bet. Okay, procedure type node is null. Seems to be a bit of a pattern of null types. But we're type checking the allocator. Come across a primary, which is a call. So that's this. This is a call. And the procedure node is I64. It does not have a data type. But it's also not going in. It shouldn't go in here. I guess when we resolve types, yeah, I think this is the same issue as just before. So where were we just before? I kind of want to undo that change that we just made. Not in here, obviously. Yeah, it was in here. This null check, because I think it was actually shouldn't have been the case, and I think it's because when we resolve our types, I have a feeling, yeah, because we resolve types in the data type, and now I think we also need to resolve types in the allocator. Yeah. Let's see what happens happens there? It crashes, obviously, but does it crash at a different place? I think so. Well, now it's resolving types, get identifier node. The identifier node is none. And none is the allocator, right? So the core allocators do not themselves have allocators. We don't get that meta. So yeah, it doesn't have an allocator. That's why the only time there should not be an allocator is with the core stuff. So I'm going to return false because I think the scenarios in which this happens, we don't need to see the allocator, I think. Let's try that. Okay. Yeah, I feel like this stuff is all looks like legit errors actually. Let's close a lot of these files. So cannot apply allocated with this, cannot apply allocated with this. And here it's saying like, what is OS? We don't import OS. And it's a bit weird, but whenever there's errors like this, these never actually get declared. So that's why it says they have not been declared. So that's legit. I think we'll take out those two because I'm happy with the error messages. And let's move this guy. So if we get OS, so he's coming out of, at the moment he's in the memory module. This is the heap allocator. But I wanted to move it to heap, to OS, and just call it heap, and so it'll be a memory allocator. I think that's it. Now os.heap should exist. I think this is because I messed a little bit with what should be namespace and what shouldn't. Remember we talked about that before? And I said only external things shouldn't be. So here the path is, what is the path? Sometimes it doesn't really show me very well. Ints is the path. Path only has one length, it's ints. We're getting the qualified name when we generate that identifier. But it's a memory allocator. Oh, how many places have I done this? Okay, looks like it was just 2 places. We're still getting that, but hopefully it's something different now. Import. That's more like what I was expecting, I think. So import. That's right. I did have an idea for this. And it's, we can take this out of here now. And the idea was around when we're type checking, I think it's in here, I thought if we grab something out of the program, instead of giving back an empty path, which then results in the path just being this import name, because this is a global thing, instead of doing that, I thought let's make a core globals path. Like that. And then we should be able to pass that in here. So what that means is that when you look for an identifier and you find a global, you'll get a path to the globals. So then this would be core globals import, not just import. And hopefully that kind of solves that. Ooh. I mean, it's taken us an hour, so maybe I shouldn't be surprised, but I'm kind of like, wow, that worked. And we got 42 printed out at the end. Okay. So I guess we tempt fate and let's try doing the tests. Okay, we get an error in the tests. Looks like we have an allocator that we weren't expecting here. Left-hand side node, allocator, stack. We have a stack allocator. So what's the qualified name of the procedure? Qualified name. Anonymous proc, anon0, anonymous proc. I guess this is the anonymous proc test. So it's to do with anonymous procedures, which I think we kind of handle here and here. Because we just take a copy of that node and make it our procedure, the left-hand side, in this case, is a stack variable. Yeah, here's anonymous proc. So yeah, the left-hand side is explicitly on the stack. So this is going to end up as a procedure with a stack allocator, which when we pass it on to generation doesn't actually make sense, because this is kind of the anonymous procedure that we're passing on. Because when we pass it on, we use this qualified name, which includes name, which for an anonymous procedure is this anon. So maybe we need to add the correct allocator here. Maybe I might just go like this. I think if it is a static procedure, we can just do this because we're not doing any of this crazy business. And I'm going to try going back to clone node. I feel like it didn't work last time, but let's try it again. So we're going to make a clone that we put in here, so then the original can get turned into a static variable so that it can get referred to nicely. And let's get the left-hand side allocator and set it to code. And see how that works. Okay, no error yet. test passed. Playground's good. OpenGL. Oh yeah, we didn't finish this. This is not valid anymore. And I actually wanted to move this out as well. I think we can just delete this memory altogether. I wanted to move it into GL. And maybe we can just, yeah, replace with buffer. And this is a memory allocator. I'm going to call this heap as well. But when we refer to it, we'll have to refer to it, because it's the GL library, as gl.heap. So it'll be obvious that we're allocating with OpenGL. We don't need these prefixes anymore. Yeah, that's that. So that actually reminds me that in our OpenGL example, we'll have to update this to be gl.heap. That's where we're allocating. We don't need this hacky business. Memory doesn't even exist anymore. Let's try that. See what happens. Boomstick was using that memory file. I think it was this. So now that would be gl.buffer. OpenGL memory has not been declared. So this also needs to be gl.buffer names. GLSL has not been declared. So yeah, so this is gone now. You might have remembered that I changed it to compute shader in some other places. So in GL again, what I want to do is add compute shader, which is a code allocator. That is itself have a none allocator. I hope this works. This is getting pretty meta. It's an allocator with an allocator. Because this is kind of just a marker. Like, this just exists so that in my OpenGL code I can go gl.computeShader. Which actually, to me, see, this looks much better now than, I feel like that's much better. It's much clearer now. We're making a compute shader. Hopefully that works. And then in that generation code, it was just looking for an allocator with the name compute shader, right? So hopefully that works. Okay, let's see. This is also because I changed the way that things get namespaced or not namespaced. But this is okay because this is hard-coded. This is hard-coded, so I think I might just move this to the bottom and set the name to this so it has the right name, the right namespace name as a global. Okay, so it starts and crashes. That's a little concerning. That's a little concerning. So normally when we get like just a crash like that, something I do is I just say, okay, let's comment out a whole lot of stuff. No crash. And let's uncomment some stuff. No crash. Let's keep on commenting. So now we're including this. No crash. Let's uncomment down to like here. Crash. Let's go back up to here. Crash. I feel like it's in this loop, which really makes me think that this new allocator is not working. And then when we go to access the data, it's bad. So let's go to the assembly. Yeah, this is the GL heap allocator. So let's have a look at that file. Oh yeah, I was like, what the hell is this? Yeah, we just another initialize 32-bit integer. Then we call gen buffers with that as the parameter. I mean, a lot of this should not have changed, I don't think. Bind buffer count. This is I guess this is storing the result in buffer names. Calling buffer storage. I mean, it's using the right registers, so that hasn't messed up, because our internal procedures use a different calling convention, but this is using the right calling convention. GeoBuffer named. I mean, I don't know. What is this? It's like an empty expression. Normally there would be like some stuff under here. One little trick we can use, haven't used this for a while. If we stash and then we run and it works, and then we rename this to OpenGL old, and then we pop our stash, so we've got all our new changes again, and then we run again and it crashes. Well, actually we should probably uncomment this stuff, because I want the assembly to be as similar as possible to the old. Oh, maybe something to do with that. Unfortunate that it crashed. Would have been nice if it didn't. Like, it looked like maybe the compiler crashed. Right? What did it do when it was like that? Oh no, invalid keyword do. Okay. Right, so let's run that again like that. And it crashes. And then let's compare the old and the new and see what the difference are. Yeah, it makes sense. We renamed those. I guess actually we want to look at the heap, right? Yeah, this is it. It's all the same, different variable names again. Okay, this is where I was like, what the hell is this expression? We're doing a return. Yeah, so here we're copying the return value to where it should go. And here, instead, we have like this empty expression. So I'm still not thrilled with how we do returns. And obviously it's broken here. So it seems like, because normally it's, at the moment it's up to the parser to determine whether there's something to return or not. And the parser doesn't know a lot. So probably when it comes across this, and it doesn't actually know what that means, it doesn't know that this here should return. So it kind of ignores this. It effectively, it does this. Just does an empty return, and then I guess it evaluates that as an expression, and it says, well, there's nothing to do. So I'm just going to put an empty expression here. So I think that's what's happened. So I guess this is not working here. Like if we explicitly put, what should it be? I64. If we just explicitly put what the type should be, which I think is this. No, it works. So that was it. I think this is another thing to do later. We're going to have to do that in CoreOS as well. Like this is not going to work. I mean, when we were using the playground, we didn't get an error, but we probably just got lucky because we kind of just did it right at the end. We didn't try to do anything later, but this was probably corrupting memory because this was not working properly. Yeah. Playground. So now if we look at the playground, so this is the OS heap. Which I guess is just one big return statement, isn't it? Yeah, okay. Okay. I think that's it. I think now we have custom allocators. So now you could create, for example, an arena allocator. That's something that I might like to make at some point. They're quite nice. But I think that's a much better allocator system. Yeah, and because it allows custom allocators, is great. Cool. All right, we're at an hour 17, so I don't think we can cut that out. I don't think there's anything else I want to try and like tackle. Any little tiny things. Context is the first parameter. Yeah, I would like to do that. That's kind of a small thing, I guess, but no, I think we'll finish here. We've had some long videos. Well, you know, the last one was pretty long, so let's just finish here. I'm happy with that. I think that's pretty cool. Thanks for stopping by. Have a good one. Ciao for now.